Hi, here we will discuss about double-ended queue. The double-ended queue is variation of the queue here which is called deck, double-ended queue, D, E and Q, deck. So here which is supporting inserting the data at both ends. In the front also you can insert the data and back side using the rear pointer also you can insert the data. Using front point you can insert the data and the rear pointer also you can use the insert data. Like that we can insert insertion. We can delete the data from both ends, delete the data from front end and delete the data from back end by using the rear pointers. So we can do deletion and insertion at both ends in doubly ended queue. That is the advantage of double ended queue. Here we will have additionally operations like accessing the first element in the queue, accessing the last element in the queue, find the size of the queue, number of elements in the queue, and is that queue is empty or not. Deck, double ended queue is empty or not. Now we can correlate the functions of deck and stack. So the size is provide you the number of elements in the double-ended queue. In stack also we can maintain the size variable to get the number of elements in the stack, and is empty in the sense which is giving the deck double-ended queue is empty or not. Here this is also provide you the stack is empty or not, and the top method which is returning the element. So this is the stack. Here the stack is having the top variable. Suppose the top is indicating the 8, so top variable is here. And doubly ended queue also, here we will use the last. Okay, first variable indicating the first element and last variable using the last element lastly entered into the queue. So now here the top element is returning uh, the element which is entered into the last, and the last method which is inserting which is returning the data which is entered into the deck last, and push is the operation to insert the data into the stack. Here push is the element which is inserted at last. Okay, last in the top of the list. So now top will be this one. So like this, insert at last, because in the stack we are entering the data at last of the stack. Okay, the front element is this one actually. So like that, the push operation denoting the last element which is inserted into the deck, and pop means we will pop up the element which is inserted at last. Okay, so the top element is inserted removed from the stack first. Like that, the last element which is denoting the element denoting the variable by last, so that is remove last, which is equivalent to the method pop in the stack. So we can implement the stack by using the deck also. Implement the stack by using the deck also, double-ended queue. So the next one we will see the implementation of queue by using the deck. So here the size is as usual returning the number of elements in the queue. In the deck also we are having size variable which is returning the number of elements in the queue. Like that, empty queue which is returning queue is empty or not. Here this is also returning the double-ended queue is empty or not, and front is here returning the first element in the queue, right? So here the front variable is denoting the first element in the queue, rear variable is last element in the. So if you want to access the first element, we can use the front variable in the queue. Like that, in the double-ended queue also we are having front variable, that is first. Okay, first variable, right? First variable, suppose 9, 10, 11, this is the last variable. So here first variable is indicating the data which is available in the first of first element in the deck. Okay, that is the method which is returning. And enqueue operation is inserting the data into the queue using the rear pointer at last. So 10 will be inserted, so now rear is incremented by 1, so rear will be the new location. So like that, here here we are entering the I mean inserting the data at back end of the queue. Like that we can insert the data in the back end into the deck into the deck by using insert last method. Insert last method, so that is equivalent to the enqueue operation in queue. And deque means delete the element from the queue that is available as a first element in the queue. So here that can be done by using the front variable. So front is now updated into the second element. Like that, in deck we can remove the first element. So here we can remove the first element. So remove first is equivalent to the deque operation in queue. So this is the way we can implement the queue and stack by using the double ended queue. Thanks for watching.